All right, here we are again doing another problem with our hypothesis test for one proportion. We have a well-known brokerage firm executive claim that 50% of investors are currently confident of meeting their investment goals. So we have a claim here, it's about a proportion here, we're confident that 50%. So our P is equal to 0.5. We know we're going to want our Q. Q is equal to 1 minus P. You might be aware that if you take 1 and you subtract a half, you get a half. Now, an XYZ investor optimism survey conducted over a 2-week period found that in a sample of 100 people, 58% of them said they are confident of meeting their goals. Okay, so we have N is equal to 100, and then from that we get our P hat also. So from our sample, we get 58%, and we write that in as a decimal here. So now, if we go back to our steps, the first step is to get our null and alternate hypothesis. So the null hypothesis, we have enough information here, almost actually. You have to read the next line. Test the claim that the proportion of people who are confident is larger than 50% at the 0.025 significance level. Okay, so our null hypothesis here, P is equal to 0.5. And we're always going to use the claim value here in our null and alternate hypothesis. The alternate hypothesis, again, test the claim that the proportion of people who are confident is larger than 50%. So now we've got P is greater than 0.50. And now we can either be left-tailed, right-tailed, or two-tailed. Looking at our alternate hypothesis, we have P is greater than 0.50, so this is going to be a right-tailed test. There. So, going down here, checking out our stuff. These are quality misses, right? We're talking proportions here, so this would be two-tailed, this here is right-tailed, so we have the correct one. And this is right-tailed. So now we need a test statistic, a p-value, we need to make a decision, and do our stuff there. Okay, so the standard error. The standard error is the square root of P times Q divided by N. And again, all of that is inside the square root. That was just bothering me for a minute. It came out to exactly 5/100ths. I was a little weirded out. Okay. So again, I like to find my test statistic so that I can make a good drawing here for my p-value. And good is loosely there. So again, with our test statistic, we're going to do p hat, and we subtract from that p, and then we divide by our standard error. And we're dealing with proportions. This is essentially a z-score. So if I grab my deal here and draw my little picture, I got my normal distribution, I've got a test, so remember zeros here, 1.6 is somewhere over here, and I am right-tailed, so this is my p-value here. So for my p-value, I'm looking for the area to the right there. And if I'm looking for the area to the right and it's a normal distribution, I have to do 1 minus the normal. And we have essentially here a normal standard distribution. And I'm going to just click on the test statistic and say true. This was 1.6, so it wasn't too bad anyway. So, I should have written this down earlier, but our alpha, we have here from the thing, test the claim that the proportion of people who are confident is larger than 50% at the 0.025 significance level. So here is our alpha. We found our p-value. Now we make a decision. If p is less than alpha, less than or equal to, we reject the null hypothesis. In this case, we do not reject. So our decision is to not reject the null hypothesis, and then our conclusion then would be there is not enough evidence at the 0.025 significance level to conclude that the proportion of people who are confident is larger than 50%. So going through here, our test statistic was 1.6, our p-value to 4 decimal places. Remember, these are probabilities, so a lot of times they are to 4 decimal places. Now if you notice here, my Excel, oops, okay, I wanted to go out a few more decimal places so that I could get this here to make sure I rounded correctly. So I have a 0, 5, 4, and then the 7 is followed by a 9, so it's going to go up to 8 there. Again, since this is greater than this, we do not reject, so we fail to reject. And then again, our conclusion would be there is not enough evidence to support the claim. Anyway. Oh, I misspelled people right here. Anyway, so again, this is a right-tail test. You want to make sure you draw your picture. It's really helpful in finding your p-value. I know I'm harping on drawing the pictures. Let's see here. We got it. Okay, so that's going to be an example here. We've got a left-tailed one, we've got a right-tailed one, and we've got some pieces along the way that we've done. So I'll probably make one more video, see if we can get a two-tailed one. Let me know if you have any questions. Thanks.